sequences. Let us look at this topic. Now, the question here is, what is a sequence? And we're talking about sequences in mathematics. Well, I would say that a sequence is a function that generates a list of numbers. And of course, those numbers would definitely have a certain pattern and be governed by a certain rule, which is the rule of the function. Now, one example that I can give you, an example of a sequence, would be, say, 1, 2, 3, 4, 5, and so on and so forth. The dots means it goes on and on, right? It goes on and on to infinity. It's infinite because I didn't end anywhere. If I ended it at, say, 100, that would be a finite sequence. It stops somewhere. But if I allow the dots just to go on and on, this is an infinite sequence because the dots go on and on and on. Another example of a sequence that I could give you is, for example, suppose I have 1, 2, alright, let me start at 2. I'm going to start at 2. 2, 4, 6, 8, 10, 12, and so on and so forth. Alright, it goes on. That's another example of a sequence. I could give you another one. Let's say 4, 9, 16, 25, 36, and it goes on. That is another example of a sequence. So you have a list of numbers, right? And you have a certain function that generates the numbers. Now, these examples actually show the list of numbers. The function itself is another matter. Sometimes you might be given, or you see the list of numbers and you're asked to figure out what is the function that generates these numbers. Then we're going to look at that. Looking at the function and then listing the numbers is much easier. But sometimes looking at the numbers and trying to figure out what was the function, or what is the function that generates them, it can be much more difficult. Alright? But we're going to look at that a bit later on. Now, sometimes there are examples of sequences in everyday life, and you see them every day or almost every day, right? For example, suppose this is you, and this is a floor, and you throw a ball on the floor. The ball hits the floor, and it bounces, and it bounces again, and it keeps bouncing, and each time it bounces lower and lower. If you consider this is the ball as it hits the floor until the ball comes to rest. If you consider the height of the ball, this first height and this second height and this third height, and each time you go on and on, the height gets lower and lower. These numbers would form a sequence, right? And of course, the function that generates it would be some function that you find in physics regarding acceleration due to gravity and the energy lost by the ball and so on and so forth. So that's a sequence that you have there. It's another issue when you have, for example, a spring. You have a spring, and it could be one of those plastic that they call spring that they call silky. All right. You might tie something small to it onto it, and you stretch it down. When you let it go, it bounces up and down and up and down and up. So the length of the spring on each bounce, that generates a sequence. All right. In waves, it could be the wave on a rope. You tie the rope here on a tree, and then you swing your hand up and down. You see the rope looking like this. It forms a sequence. In any other wave, water wave, electromagnetic waves, right, sound waves, whatever type of wave, it's a sequence. Even in other cases like say population growth or decay as well. If you have a graph, and this is time and this is population, right? It could be humans, it could be any animal, it could be bacteria, whatever. You start with a certain number, and over time it grows like that. And at one point you have a certain population. It could be in a certain year, in another year you count the population again, or in a decade. The census is done every decade. So every 10 years you have a census and they record the population. And you see the population growth like that. It could be also you're in a science lab and you have a culture of bacteria and you're seeing how they grow. Alright? As the population grows, each number would form a sequence. It could also be that you have a pot of hot water and you turn the stove off, and every 1 minute you take temperature, or it could be every 5 minutes. You measure the temperature and you plot. This is time, this is temperature. Say T for temperature here, or TMP. And over time, you see the pot getting cooler and cooler. At 5 minutes, 10 minutes, 15 minutes, and you see the temperature dropping. Alright? And then the temperature will drop to the room temperature after a long time, and it doesn't get any cooler after that. So those numbers form a sequence. Could be the level of traffic during times of the day, or the level of human traffic in a supermarket, right? Every Saturday you have a maximum traffic. Everybody comes out to shop, right? It could be the amount of money you have in an account every year as you get interest, a fixed deposit account, and you reinvest it. So you have many cases where sequences exist in real life, in everyday life. You have all sorts of examples in which you have sequences. Alright? Alright, now let's call time on this video for now, and we'll continue looking at sequence in another video. So I will see you then.